All right, good evening, guys. Welcome to my video channel again. This is Mr. Nie, and today I'm going to record my solution for 2019 Mathematics Exam 1. So let's begin. Question 1. Let f of x be a function restricted on 1 on 3 to infinity, where f of x is 1 on 3x minus 1. Find f dash of x. Okay, so you're going to recognize the pattern. It's pretty obvious. 3x minus 1 to the power of minus 1. Recall that if you have a function, especially a linear function, to the power of n, the derivative with respect to x is n times a times ax plus b, and to the power of n minus 1. So your f dash of x is apparently minus 1 in the front, because I'm bringing down the power to the front, and multiplied with 3, the inner derivative, and 3x minus 1 to the power of minus 2. Okay, so you should have minus 3 on 3x minus 1 to the power of 2 at the bottom. Okay, that's your answer. Next one, find an antiderivative of fx. Remember, your x is greater than 1/3, as stipulated in the start of the question. So 3x greater than 1 and 3x minus 1 greater than 0. What does that mean? That means you don't need to worry about the absolute value. Therefore, an antiderivative will be given by the integral of 1 on 3x minus 1 dx. Okay, so your solution should be, okay, 1 on 3 log e bracket 3x minus 1 plus c, okay? Alternatively, if you take out 3 as a, let's say, a common factor, the bottom will be rearranged to something like 1 on x minus 1 on 3. Therefore, your antiderivative could also be written as log e bracket x minus 1 on 3. But this time, you will have another constant, c1. If c equals 0, and antiderivative is 1/3 log e 3x minus 1, or 1/3 log e x minus 1/3. Okay? That's just two possible options for you to look at, right? Either one will be correct. Okay, next one. Let g be a function restricted on all real values except for minus 1. And this is given by a quotient function. So you are going to use quotient rule for this function. All right, we want to find the value of g dash at x equals 1. So we say let u equals sine pi x, v equals x plus 1. And I calculate u dash and v dash respectively. I will get pi times cos pi x and 1 respectively. Now I'm going to say g dash of x equals u dash times v minus v dash times u. Whole thing is divided by v squared, which is a long vinculum. U dash is pi times cos pi x times x plus 1. The vinculum is not long enough, then I need to extend it. Minus 1 times sine pi x. The whole thing divided by x plus 1 squared, which is your v squared. Okay, now your g dash 1 will be pi times cos pi times 1 plus 1 equals 2 minus sine pi. And the bottom will be 1 plus 1 squared. Okay, now let's look at each part carefully. Pi times cos pi, which is -1, times 2, minus 0. Sine pi is 0. The bottom will be 4. Therefore, your final answer should be minus pi on 2. Okay? Not very hard at all. It's this guy again, 1 over 3x minus 1. So many variants of one simple function. So let's look at the basic graph. If I have 1 over 3x minus 1/3, this will mean I have two asymptotes. Vertically, I have x equals 1/3. Horizontally, I will have y equals 0, okay? Because when x approaches to infinity, 3x minus 1 will approach to infinity, and 1 over 3x minus 1 will approach to 0. Okay, we want to find the rule for f inverse. So let y equals f of x. Swap x and y for inverse. So you have x equals 1 on 3y minus 1. And your 3y minus 1 will be 1 on x. And 3y equals 1 on x plus 1. So y equals 1 on 3x plus 1/3. Okay, now you just need to state the rule for f inverse. Therefore, f inverse of x will be 1 on 3x plus 1/3. And the domain is automatically domain f inverse is your range of f. What is my range of f? If you quickly draw a diagram, you will see this is your vertical asymptote. This is your horizontal asymptote. And you should have y equals 0, x equals 1/3. The graph will roughly look like, okay, here and here. Like in first and the third quadrant. This point will be 0, minus 1, if I'm not mistaken. So your range of f is all real values excluding 0. Okay? X cannot be 0 because it's the denominator of your f inverse. Okay, now I need to relocate my answer. Let G be a function obtained by applying the transformation T, which is this guy here, to the function f, where C, D are real numbers. Find the values of C and D, given that G equals f inverse. So my target is making f of x equals 1 on 3x minus 3rd. To match G of x equals 1 on 3x plus 1/3. By comparison, I would say, okay, I'm getting rid of the minus 3rd behind this x. So it will be a purely x at the denominator. The first one is translated by 1/3 unit left. The second translation will be translated by 1/3 up. Therefore, in your matrix, your value of C will be minus 1/3, because moving to the left, a shifting to the left means a negative horizontal translation. And moving up means positive vertical translation. So your D value will be 1/3. Okay, easy. Question 3 is a simple discrete probability question. The only possible outcomes when a coin is tossed are a head or a tail. Let's name them. Head, tail. When an unbiased coin is tossed, the probability of tossing the head is the same as the probability of tossing the tail. Jo has 3 coins in her pocket. 2 are unbiased and 1 is biased. When the biased coin is tossed, the probability of tossing the head is 1/3. Jo randomly selects a coin from her pocket and tosses it. So selection first, tossing next. It's a 2-stage experiment. 2-stage experiment. Now, if I start my experiment, the first stage is choosing a biased coin or unbiased coin. And then for a biased coin, I could have either head or a tail. For unbiased coin as well, it's also H and T being its outcomes. So I need to calculate the proportion of biased coin and unbiased coin. We have 2 unbiased coins, so the probability of getting an unbiased coin is 2/3. The rest, the only one left is the biased coin, which is 1/3, the probability of that. If I have a biased coin, then the probability of getting a head is 1/3. Then getting tail is 2/3. On the other hand, I have unbiased coin and head and tail. So I should have, okay, this is half and another possibility is half again. For Jo to toss her head, let's say head, which means if it's a head from a biased coin plus a head from unbiased coin. Formally, in probability statements, you should have, okay, this is H given B times probability of B plus probability of H given unbiased coin. All right, I'm occupying too much spaces with my tree diagram, so let me relocate my tree diagram to here. Then I should write probability of unbiased. What is my probability of H given B? H given B is this 1/3 here, times probability of B, which is 1/3, plus probability of H given unbiased, which is half, times probability of unbiased coin, 2/3. So you will have 1/9 plus 1/3, which gives you 9 at the bottom, 1 plus 3, which is 4 on 9. Okay? Now, we want to find the probability that she selected an unbiased coin given that she tossed a head. So, I want the probability of getting an unbiased UB given that H. This will be re-expressed as UB intersecting H divided by probability of getting a head. What is my UB intersecting H? What is the probability of that? Look at the previous working we have done. Unbiased, this guy here comes from here. So I'm just writing these down. This will be half times 2 on 3 divided by 4 on 9. The top will be 1/3 divided by 4 on 9, which is 1/3 times 9 on 4. Canceling down gives you 3 on 4. That's your answer. I missed a part. This should look better. Okay? All right, easy. Question 4 is a simple trigonometric problem. Solve 1 minus cos x on 2 equals cos x on 2. Nothing special, very similar to the equation solving question in 2018 Mathematics Exam 1. So the first thing I'm going to do is rearrange it. I have 2 cos x on 2 equals 1. Looks like I used the wrong color. Doesn't matter. Let me switch it to another color. Much better. I love technologies. Cos x on 2 equals half. Now, my working domain is not x. This is my initial domain for the variable. Because I'm looking for the value of x on 2, I need to divide every endpoint by 2, which gives me minus pi as my left endpoint, pi on 2 as my right endpoint. So I'm looking for special values within this domain. This is my working domain. Now, let's think about some special values. I know cos pi on 3 should be half. How about other possibilities? If I'm using my simple diagram of all station to Camberwell, looks like I have extra fondness of this location, Camberwell, because in the past, I lived in Camberwell for almost 6 years. I do have some fondness with this old suburb. Okay, A, S, T, C. Here is my first base angle, theta, which is pi on 3. Then I need to think of, all right, positive half. I could also have an angle in quotient form, which aligns to C. So here I can use either 2 pi minus theta or just minus theta itself. Because 2 pi minus theta will be too large, I would say I would choose minus theta. So you only have 2 possibilities. Half x is pi on 3. And it could also be minus pi on 3. But don't forget, I'm looking for x. So your x value should be 2 pi on 3 minus 2 pi on 3. Okay? Only these 2 solutions. The function, all right, minus 2 pi to pi, that's my domain. And here I have this one, cos half x. Let g be a function on the same domain, but with the different rule 1 minus f of x. So this is 1 minus cos half x. If I'm trying to make a connection between gx and fx, this is actually your g of x. This is your fx. So part A, what we are doing in part A is actually looking for the x coordinates for the point of intersection between f and g. Right. It should give us some hint. What sort of hint? If I have x equals 2 pi on 3, then for f 2 pi on 3 is actually cosine half 2 pi on 3, which is pi on 3, giving me half. Therefore, I should have a location, a point, 2 pi on 3, y equals half. So the graph should go through here and here. Okay? Now, another thing is, if I'm doing a reflection with the minus here, the graph should roughly look like, okay, that. And that, right? Finally, I should deal with the one at the beginning. It's upward translation, an upward translation. So the whole graph will be translated above by 1 unit. Do you guys get what I mean here? And also, it should pass through the 2 blue points I marked on the original graph. All right, now I have the rough idea where the new graph should go through. Here, 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 and here. It should also have some sort of symmetry. Like this. You guys can clearly see the pattern I'm drawing on the diagram. Therefore, I'm connecting all these dots with smooth curve. Forgive my shaky hands because I'm manipulating the answers on an iPad. On the actual paper with the actual pen, I will definitely perform better, okay? So this point is 0, 0, yes. Point of intersection, that's 2 pi on 3, half. And this is minus 2 pi on 3, half. Your endpoint should be pi 1, believe it or not. Minus 2 pi and 2, believe it or not. All right, endpoints of G, yes. Coordinates, yes. All points of intersections with coordinates, graph and G, yes. Shape should be all right. Okay, done. If you are still not very satisfied with the final drawing, you could use a thicker pen to go through all the points again, like that, okay? All right, should be okay. Let's move on. Question 5. 5 marks. We want to evaluate f minus 1. So f minus 1 should be 2 over minus 1 squared plus 1, which is 2 on 4 plus 1. That should be 3 on 2. Yes, that's it. Okay, now, if I'd like to draw the graph, with part AI, I actually had one extra piece of information. When x equals 1, y equals 2, 3 halves. So minus 1, 3 on 2, which is 1.5, should be this point. And I should recognize this is a truncus. A truncus has an asymptote of x equals 1, y equals 1. So using your ruler, and a ruler will be helpful. Okay, now it's time to label all asymptotes with the equations. Because I know a truncus will be symmetrical around its vertical asymptote. For this point here, I would say another point on this truncus will be here. Therefore, I will mark in this symmetrical point. Of course, I do need to take care of some important points like axial intercept. For example, f of 0 gives you the location of y-intercept. So this will be 2 plus 1, which is 3. Using the idea of symmetry, you should get another point, 2, 3. Now it's time to connect all these dots. And make sure you draw the graph really carefully, like that, and draw the graph as symmetrical as possible. Okay? All right, that should be enough, but let me just locate the points as I'm drawing. Okay, that should be enough. Find the area bounded by the graph of f, the x-axis, f, the x-axis, -1 and 0. So I should have my area for -1, the axis, and the graph of f. In the middle, that's the area I'm looking for exactly. And I should use integration. Area equals the integral from -1 to 0. Then I should have 2 over x minus 1 squared plus 1. The whole thing anti-differentiated with respect to x. What I'm doing now is rewriting this one to actually, what should I do here? Let's try something special. But warning, if you try that one, you must get your answer correct. Otherwise, you could be penalized because I'm about to use some strategy not taught in math method. Let u equals x minus 1. Then my du dx will be 1. Therefore, du equals dx. Okay? And when x equals -1, my u will be what? My u will be -1 minus 1 minus 2. When x equals, let's say, 0, my u will be -1. Therefore, I'm actually changing the variables. That will be u equals -2. That's my u equals -1. And here you should have 2 over u squared plus 1. And here you should still have du because du equals dx. Now this is going to be -2 to -1, 2 to the power of 2u minus 2 plus 1. Whole thing anti-differentiated with respect to u. So this is -2, this is -1. You will be getting towards -2u minus 1 plus u, which is -2 over u plus u, -2 to -1. And let's see how it goes with that. -2, -1, -1. That's your upper bound substituted into the integrand, the antiderivative, sorry. And then you end up with -2 over -2, -2. So this time I have 2 minus 1 minus plus 1 -2. You could have 1 minus -1, which should be 2. That's an interesting answer. Okay, let me double check. I set up the correct integral. Yes, it's from -1 to 0. Yes, and the graph is above. The region is above x-axis. And let's see. Yes, that should be correct. This is my typical quote. Play it, what's that word? Fancier. Play it safer. It's your choice, okay? Another strategy, another way to solve this problem is using that formula. Antiderivative of ax plus b to the power of n gives you ax plus b, n plus 1 divided by a times n plus 1 plus c. Okay? Moving on. Aha. Fred, that guy, must be a rich guy. He owns a company that produces thousands of packs each day. Ah, packs. Actually, I don't quite like eating packs. He randomly selects 41 packs that are produced on one day and finds 8 faulty packs. Proportion of faulty packs. So it's small p hat. 8 out of 41. All right, packs are packed each day in boxes. Each box holds 12 packs. Let p hat, big p hat, be the random variable that represents the proportion of faulty packs in the box. So my total number of packs is 12 in one box. The actual proportion, okay, actual proportion of faulty packs is 1/6. So that's my p-value, small p-value 1/6. Find probability p hat smaller than 1/6. Express your answer in the form a times b to the power of n. A, b are positive rational numbers, and n is a positive integer. So this is specify the required form of the answer. All right. If I had no clue at all how to proceed this question, then what should I do? Never forget, whether you are a math talented student, a genius, or you are not that capable, you should always look at the formula sheet. All right? No difference. Everyone is treated the same. You have to look at the formula sheet. Because I know I'm doing probability questions, sample proportions. Ah, excellent. That's what I need. Let me quickly take a screenshot of that one and refer to that guy here. A nice little formula. That's too big. Let's make it smaller. All right. If I'm referring to that little formula here, what does big X represent? What does n represent? All right, n is 12, right? So if you multiply both sides by n, your X will be n times p hat. Therefore, the original probability p hat smaller than 1/6 could be re-expressed as n times p smaller than n times 1/6. What is your n value? N is 12. So your probability statement will be big X smaller than 12 times 1 on 6, which is 2. But notice this is a discrete case of probability question. Therefore, X can only be what values? Integers, right? So X can only take the value of 0 and 1. Finally, what is X? Look at the only outcomes in this experiment. You only have good pegs or faulty pegs. This is 1, this is 0, so it's a Bernoulli trial, okay? Bernoulli trial. And you have 12 experiments independent of each other. Then your X is just binomial, okay? Binomial 12, 1, 6. The probability mass function is X equals small x, 12 choose small x. How many times of success? That's X. How many times failure? 12 minus X. All right, now looks like I have some ideas from getting no clue at all to knowing how to proceed. So I'm going to calculate probability of X equals 0 and X equals 1. Forgive my worst handwriting, and I'm going to substitute the two values. So the first one will be 12 choose 0 times 1 on 6, 0, 5 on 6, 12, plus 12 choose 1 times 1, 6 to the power of 1. Then 12 minus 1 is 11. I only have 11 good pegs and one faulty peg. 12 choose 0 gives you 1. Then that's 1, 6, 5 on 6 to the power of 12, plus 12 times 1, 6, 5 on 6 to the power of 11. What should I do next? Okay, that could be written as 1 on 6 times 5 on 6 times 5 on 6 to the power of 11. Plus, cancel out, you get 2 times 5 on 6 to the power of 11. So I'm actually creating a common factor for you to proceed your simplifying. And the first term will be 5 on 36 times 5 on 6 to the power of 11 plus 2 times 5 on 6 to the power of 11. Then taking out 5 on 6 to the power of 11, you should get 5 on 36 plus 2. And I know I should double check. All right, 5 on 6, then to the power of 11 times 5 plus 72, which should be 78 on 36. No, actually 77 times 5 to the power of 5 on 6 to the power of 11. Did I do something interesting? Let me double check. Something does not look quite right. I need to have a look. Shouldn't be that interesting. I see where I went wrong. Look at here. I'm sorry, guys. I did not do this on purpose. I just experienced some mental blank. So this will be 0. I did some transcription error. See? If you want to check your answer, go back to each working step, step by step. Here, that's your 0, okay? All right, let's pick them up. Then you should have 5 on 6. 5 on 6 to the power of 11 plus 2 times 5 on 6 to the power of 11. This looks much better. 5 on 6 plus 2. 5 on 6 to the power of 11. Then you should have 6, 5 plus 12, which is 17, times 5 to the power of 5 to the power of 11 divided by 6 to the power of 11. So it's 5 on 6 to the power of 11. All right, that's your correct answer, I suppose, in the form of a times b to the power of n. But the question does not want you to specify what values a and b are. So stop it here. Okay, now, probability question finished. We waste a couple of minutes, but don't worry, we'll make it up. The graph of the relation y equals square root 1 minus x squared is shown on the axis below. P is a point on the graph of this relation. Another point is minus 1, 0, and x 0. X 0, that's your, okay, it's this point here. Find the expression for the length PB in terms of x only. So, this is x. Length of this length is 1. If this one is y, okay, that should equal to 1 minus x squared. All right. So an expression for the length PB. Length PB equals y, which is 1 minus x squared. Notice that the domain should be minus 1 smaller than equal to x smaller than 1. And I want to find the maximum area of the triangle ABP. So, what's this nice looking curve here? It's actually half unit circle, guys. It's a half unit circle. What does that mean? Thinking back to year 11 stuff. All right. How do we define an angle in a Cartesian system? It's a point along the unit circle, and the positive direction is anti-clockwise direction. What else can we recall from that memory? This point can be expressed as cosine theta, sine theta. Don't they? So I have two expressions involving an unknown variable theta. And I should have, okay, the area of this triangle is half AB times PB. Half times base times height. Okay, half AB is x plus 1 times y. What is x plus 1? X is this guy here. This is your x. This is your y. Therefore, your A will be half. Let's say this is cosine theta plus 1. times sine theta. Definitely, I know the theta value can start from 0, yeah, when it's here, or it will end up here, smaller than pi. Okay, now, if I take the derivative of a with respect to theta, then you should have half derivative of the first one times the second one. So it's minus sine theta plus, what else? Cosine theta plus 1 times the derivative of sine, which is cos theta. Moving on, half bracket minus sine square theta plus, okay, that's cos square theta plus cos theta. If only this is a positive sine square, then I could just use sine square plus cos square equals 1, isn't it? But no, not the case. I need to do some further substitution. Let's try to use minus 1 minus cos square theta plus cos square theta plus cos theta. Therefore, I end up with half 2 cos square theta plus cos theta minus 1. Okay, now with this expression here, the purpose of the a d theta is to be equated to 0 for maximum or minimum. And I should have, okay, 2 cos theta. Let's make it to 0. 2 cos theta, and 1 minus 1. Therefore, it yields cos theta equals half. Then my cos theta equals -1. But when cos theta equals -1, it's at this location, giving us 0 area. 0 area. So reject it. If I have cos theta equals half, then my sine theta is definitely √3 on 2, isn't it? So my area will be half times, look at this bit here, guys. I'm referring to that. 1 plus 1, 2 times the value of sine theta when theta equals pi on 3, okay? So half times 3 on 2 times √3 on 2 gives me 3√3 on 8. Okay? That is just my suggestion. Another possibility is, I will write it in the bracket here. It can be written as half x plus 1 times x1 minus x squared to the power of half. Then you take the derivative with respect to x, getting dA dx. But it may involve more arithmetics or more potentials to make mistakes. So that's just why I'm using simple functions like cos and sine. But definitely you need to know your identities, okay? Sine square can be re-expressed as 1 minus cos square. All right. Finally, let's have a look at the other questions. Okay, question 8. The function f is restricted on all real numbers. F of x is a polynomial function of degree 4. Part of the graph is shown below. Touches the x-axis at the origin. All right, so this is a repeated root. definitely you have x squared. That's x plus 1, that's x minus 1. But does that mean it can be written as x squared, x plus 1, x minus 1? Not necessarily, because it's an inverted quartic function. It should have a minus in the front, but you still need to take care of these two turning points. They are symmetrical, so either one substituted in the formula, I mean that one, should be left-hand side equals right-hand side. So I might say, let's define another unknown variable, big A. Okay, with x equals 1 on root 2, y equals ax squared, x squared minus 1. So x squared will be 1 on 2. X squared minus 1 equals minus 1 on 2. And my y is correspondingly 1. So doing the substitution gives us 1 equals a times half times minus half. Definitely the leading coefficient is not minus 1 or 1, guys. This is a big trap. Last year, a lot of students made big mistakes here, losing this important 1 marks. Subsequently, the rest of the questions, without the correct result from this part, can't be reached. All right, minus 4a equals 1, giving us a equals minus quarter. Now, what am I thinking here? The other way around. Maybe today I'm not in a very good mood of doing exam solution, but anyway, with my perseverance, I will finish it to the best of my ability. Never give up. And don't forget to restate the rule of f. Therefore, your f of x, which is this y here, f of x should be minus 4x squared times x squared minus 1. Okay? All right. Let g be a function with the same root as f. So h of x equals log e g, which is log e f, isn't it? Let me just drop down this formula here. Look at the little manipulation I'm using here. I'm taking out the common factor x squared. So what should I do next? I know this is a sum of two functions, or sum of difference. If you have h equals f plus or minus g, then the domain of that equals domain f intersecting domain g. So I'm going to find the domain of that and that respectively. All right. The first part is log e g of x, which is log e that guy here. If I want the log e to be defined, I must make sure this bit is greater than 0. So from this point, open circle, to this point, open circle, to this point, open circle. All right, therefore, let's drop it down. Domain natural log g of x is a set of value of x such that g of x is greater than 0. From the diagram, minus 1 to 0, union 0 to 1, excluding 0, okay? Now, for domain natural log x squared x plus 1, it's a set of values of x such that the inner function is positive as well. Let's look at this bit. I know this x squared should be a touching point at 0, and this is a distinct root. Therefore, your values of x should go from -1 exclusive to 0 exclusive, then to infinity. But let's just write it as -1 to 0, union 0 to infinity. Finally, I'm going to make the intersection of them. Intersection, okay, the common part. Therefore, my domain of H, which is D, should be the intersection of that guy and that guy. So taking the smaller one, we have -1 to 0, union 0 to 1. Okay. That is my effective domain. Quite a bit calculation, but just be very careful with your diagrams and calculations, okay? Step by step. All right. Don't forget we still have this h of x. If I dropped it down, don't overlook what I have written down. State the range of h. Of course, I need to have the equation of h. So let's look at this one. Don't forget my x values are going from -1 to 0, union 0 to 1. And my range of h is produced over these values. All right, if I'm using my logarithmic laws, I should have -4x squared, x plus 1, x minus 1, over x squared, x plus 1. Therefore, these two terms can be canceled out. These two terms can be canceled out. What we end up with is log e minus 4, x minus 1. So this is a simple linear transformation of a logarithmic function with natural number as base. Let's look at the diagram. Initially, logarithmic function has shape like this. That's y equals natural log x. With this -4 here, you are actually reflecting the original function around. So how does that look like? You should have a -1, x equals -1 as your vertical asymptote, okay? And it's reflected around. So when x is approaching to 0, because this one is an open circle, your h of x will be natural log -4 times -1, natural log 4. So an open circle y-intercept, quoted y-intercept, okay? It's not really an y-intercept because it's an exclusive. Now, what else? I know it should look like that, but how exactly? When x approaches to -1, my h of x will be getting closer to -4 times -2, which is 8. Okay, should be higher than natural log 4. That's -1 natural log 4. All right, finally, when x goes towards left-hand side of 1, my h of x will get towards -infinity because it's going down, 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 down. Okay, so my range should go from this one to the biggest one, smallest to the largest, excluding any discontinuity point. range of h equals negative infinity, natural log 4, exclusive, natural log 4, natural log 8. Okay? All right, should be enough. Oh, look at these bloody 2 marks. Yeah. All right. Anything else? Last but not least, let's have a look at this one. Composite functions. Consider the functions f defined on all real numbers, g defined on all real numbers. State the rule of g of f. I'm substituting f into g, which gives you g of f of x. Let's say it's y1, okay? E to the power of minus x squared plus 2x plus 3, all in the power. Okay, find the values of x for which the derivative of g of f is negative. So I'm actually looking for, let's name it as y1, okay? Let y1 equals, I don't want to write it again, so let's just copy, paste. I know my dy1 dx will be g dash of f times f dash of x, which is the original function itself, because the derivative of exponential is still itself. But don't forget f dash of x. What is f dash of x? So it's 2 minus 2x, okay? Coming from this one. Now, with this expression, I could do a bit simplifying, taking out the 2 times 1 minus x. All right, the pattern seems much more obvious. Now I want the y1 dx smaller than 0 because the gradient, the derivative is negative. But 2e to the power of minus x plus 2x plus 3, whatever value we take, it must be positive. Therefore, I can only have 1 minus x, the linear term, negative. So my x will be greater than 1. Actually, I would like to spend 1 or 2 minutes talking about the shape of that. When we are learning normal distributions, we know the general form f of x, the PDF function, is 1 over root 2 pi e to the power of minus x squared over 2. And the shape is like a bell-shaped curve, okay? It means, okay, this guy here is just a simple translation of the quadratic function, a negative quadratic. So I guess the graph of y1, which is this guy here, should have a similar graph like that, all right? Therefore, I would say the graph of y1 looks like that, okay? Similar to the bell-shaped curve. Okay, state the rule of fgx. This time, I'm actually substituting g into f. So let's say fg of x equals 3 plus 2 ex minus ex to the power of 2. And you should have 3 plus 2ex minus, be very careful here, don't write e to the power of x squared, no. That's e to the power of 2x, okay? Notice from year 10 onwards, if you have something like that, it's actually an times m, okay? That's your basic index laws. So don't get yourself confused, right? And I want to solve f g x equals 0, which is looking for the x-intercept for f of gx, the graph of f of gx. All right, if I'm making this one to 0, I'm actually making this one to 0 as well. So why don't we just dropping down this bit equals 0? Now, what does the pattern look like? It's actually a quadratic, okay? So if I'm reversing all the terms, I will have that guy here, isn't it? And I'm treating e to the power of x as the whole variable. Putting a -3 and 1 here, do some cross multiplying, you should end up with -2 in the middle. So ex minus 3 equals 0. Ex plus 1 equals 0, which is never possible because we know all exponential terms must be positive or approaching to x-axis. Stating your reason, ex greater than 0. Therefore, my only possibility is ex equals 3, and x can be expressed using natural log e. All right, that's the only solution. Okay? So, don't forget to restate your solution. The solution is x equals log e3 only. Thank you, Mr. Box. Find the coordinates of the stationary point of the graph fgx. So, I know let y2 equals fg of x, which is 3 plus ex with the 2 here minus ex e2x. So the y2 dx equals 0 plus 2ex minus 2e2x. Okay? Don't you ever dare to write down -1 here. No, it's not a power function. Can't do things like that. Taking out 2ex, 1 minus ex equals 0 for stationary points. Again, ex is greater than 0, so 1 minus ex equals 0. Ex equals 1. X will be what? E to the power of 0 is 1, so x is 0. But I need the coordinates, guys. The coordinates. So x equals 0, y2 will be 3 plus 2e0 minus e0. 5 plus -1, which is 4. Therefore, the stationary point is 0, 4. Okay. Lastly, the only mark left. I would call this one ice on top of the cake. Under the exam time limits, you will feel much more pressure than what you were experiencing during the year. So, if you encounter the very last part only worth 1 mark, just guess. 0, 1, 2. That's it. Guessing the solutions. But actually, I'm going to do this question properly with a proper analysis with some nice diagrams. So g of f is my y1, f of g is my y2. So I'm actually looking for y1 plus y2 equals 0, which means in the aspect of looking for points of intersections, I would make it like that. Y1 equals minus y2. I'm actually rewriting the equation as if it's looking for some intersection points, equating two functions. So it's actually equivalent to finding the intersections between graph of y1 and minus y2. So how does my graph of y1 look like? Let me draw a rough sketch here. I know from part B, we know this graph, a bell-shaped curve, should give us a good estimate of the general shape. And the turning point is x equals 1. When x equals 1, y1 should be e minus 1 plus 2 plus 3, which is e to the power of 4, isn't it? It's a very large number because e is like smaller than 3 but greater than 2. Think of 3 to the power of 4, it's like 27 something. Okay, so here you have your x coordinate 1. Let's treat this one as e to the power of 4. And I know after this point, it's decreasing because the gradient is negative and approaching to 0. Y equals 0. When you have a 0 here, you actually have, okay, 3 plus 0 minus 0, which is 3. So this point should be 0 e to the power of 3. And don't you ever forget the asymptote. Y equals 0, isn't it? Now with this one, I would say, okay, I have my graph of y1. So this is y1, okay? How about minus y2? Minus y2 should have, okay, if it's y2, positive y2 has a stationary point at 0, 4. 0, 4 should be roughly here or here, even lower. That's 0, 4. If you reflected that around with a negative sign, it will be 0, minus 4. How about the solution obtained from part D? Ah, that's log E3. Log E3 is definitely greater than 1 because log E is 1, log E3 must be greater than 1 because 3 greater than E. That's assumed knowledge. Okay, now I can join these two. Natural log 3, 0. And if I'm extending the graph like that, that's one point of intersection, okay? Then I just need to predict how the graph will look like before x equals 0. Have a look at the equation. Y equals 3 plus EX, 2EX, sorry, minus e to the power of 2x. If x gets to a very small number, like negative infinity, then e to the power of x will get towards 0. e2x will get towards 0 as well. Therefore, y2 will get towards only the constant 3. And I would say minus y2 will get towards minus 3. Okay, so if this one is minus 4, minus 3 is just a little bit higher than this point. The graph will have a partial asymptote, which is this guy here. Quite demanding, this question. Okay, minus 3. All right, that should tell us the story. That should be the end of story. If you want to investigate further, okay, when x is approaching to infinity, minus y2 equals e2x minus 2ex minus 3. This one increases very fast rather than ex because of the proportionality constant 2. If this one is squared, it will definitely compensate the effect of negative infinity, much greater than that one. And it's also greater than -3. That's why minus y2 will get towards very large number. Okay, that's why it's getting higher and higher, drastically higher. All right, don't forget just to answer the question, number of solution. 1. Thank you, Mr. Box. We finished this devastating question desperately. Finally, very demanding, very demanding. All right, I think despite some mistakes made during the process of recording the video, we fixed it up. Don't worry too much. Hopefully, the details are all squared or rectified. If you have any problems, just go back to somewhere you don't quite understand and look at it patiently. I hope this video could help you in some way. More videos coming. Thank you for watching and see you next time. Bye-bye.